So to start off with, let's look at translating curves. So a horizontal shift, we simply get our basic curve and shift it horizontally a certain amount. Okay, so function x minus h. If we replace x with x minus h, we'll get a shift horizontally. Now, depending on whether h is positive or negative, we'll move it to the left or to the right. Now, if you're ever unsure of which way to move it, have a look at that x minus h and say to yourself, what would make this equal to 0? And then that's where the origin's been moved to. So the 0's been moved to. A vertical shift, instead of replacing the x, we replace the y. So we replace the y with the y minus k. So y minus k would become function x. Now, you don't normally see it like that, of course. You're probably normally used to seeing it like that. If you add a constant to it, we shift it up or down. But really the idea is, no, if you replace y with y minus k, and then it keeps the same idea. So when I replace it with the y, because y represents vertical, it's a vertical shift. When I replace the x, it's a horizontal shift. Okay, and again, if ever you're unsure, solve that y minus k equals 0, and that'll tell you where it's been moved to. So all right, how now do I draw this? I've completed the square. I know it's a parabola, of course. And I've completed the square on the quadratic and come up with x minus 3 all squared plus 4. Now, let's say I've forgotten that tells me where the vertex is straight away. How do I do it? Well, all right, I know it's the basic curve. I started with the basic curve, y equals x squared. But then it's grouped with the x, negative 3. So I've shifted it right 3 units. Okay, but then that plus 4, which is really y minus 4, means I've shifted it up 4 units. So there's our new graph. It's our parabola, vertex of course at 3, 4. Now we can apply that idea to any shape. This one here, it's a bit hard to tell until I, again, complete the square. But I'm going to have to complete the square on both the x and the y. So half the coefficient of x would be 1, so I get x plus 1 squared. Half the coefficient of y would be negative 2. So I get y minus 2 all squared. Can't change the question, of course. So I then add all those numbers to the right-hand side. We end up with equals 9. So all right, what do we got? We know we've got a circle then. The basic curve is x squared plus y squared equals 9. But now we've got shifts happening. Well, grouped with the x is plus 1. So I've shifted it to the left 1 unit. Grouped with the y, it's minus 2. So I've shifted it up 2 units. And there's my circle at the centre. Minus 1, 2. So y equals 2x squared plus 8x plus 5. Well, it's much easier to complete the square with 1x squared than 2x squared. So I'm going to divide everything by 2 first of all. Complete the square on that and eventually we end up with y equals 2, because you'll notice after I've completed the square, I've multiplied by 2, so I've got y the subject again. So y equals 2, x plus 2 squared minus 3. So all right, it's our basic curve, y equals x squared. The curve gets steeper, because instead of x squared, we've got 2x squared. We'll talk a bit more about steepness and shallowness later, but essentially that makes it steeper. We've shifted it left 2 units, and we've shifted it down 3 units, and there's our new parabola. So that's basically our horizontal and vertical shift. Reflecting curves then. So a vertical reflection is when we replace the x with negative x. So x is negative x. So when instead of substituting 1, you substitute negative 1 and so on. So that's why you get a reflection vertically. So function negative x. It will end up reflecting in the y-axis because, as I say, it's a vertical reflection. Now, that's in the y-axis. If you wanted to reflect in a different line, what you do is you replace x with 2a minus x. That'll reflect in the line x equals a. So it sort of combines the reflection with a horizontal shift as well. Let me show you. There's y equals function x. If I was to reflect it, there's function negative x. If I was to shift that 2a, then I'd be over there, function 2a minus x. But now have a look at my final curve and the original blue curve. It actually is a reflection in x equals a. So that's why you shift it 2a, not a. We can do the same thing horizontally. Horizontally, we replace the y with negative y. So we end up with negative y equals function x. Well, we don't normally see it written like that. We normally see it as y equals negative function x. But again, in reality, it's the negatives with the y telling us it's the y values that are being affected. So that would reflect in the x-axis. But again, if you wanted to reflect in a different line, this time you replace the y with 2a minus y. Well, that will end up being then y equals 2a minus function x. So there's y equals function x. That would be y equals minus function x. Shift it up 2a. Now have a look at the final curve and the original curve. Again, they're reflections in x equals a. Now, if you want to reflect in the origin, what? How do you reflect in a point? Well, that's rotational symmetry, if you like. But look what happens. It's basically y equals minus function minus x. That gets you the rotation of 180 degrees because you're reflecting both vertically and horizontally. And the effect of that is a 180 degree rotation. So let's do it by this one. Y equals function x. Okay, there's y equals minus function x. I've reflected it in the x-axis. Now that picture I'll reflect in the y-axis. And now if you compare the first graph to the last one, you can see, oh look, I've rotated the graph 180 degrees. So a rotation of 180 degrees minus function minus x. No coincidence that that is an odd function. If you think about, do you remember the test for an odd function? Minus function, and odd functions have rotational symmetry. All right, let's try this one. Y equals minus x plus 1 cubed plus 2. So the original graph is a beautifully drawn y equals x cubed there, I'm sure you'll agree. We are going to reflect in the x-axis because you see the minus sign is with the y, it's not with the x. The x is inside the grouping symbols. I could, if I wanted to, multiply by -1 and the y would become the negative. So it's a reflection in the x-axis. Now, we have a horizontal shift. What makes that equal to 0? -1. So shift it left, -1. And then we have a vertical shift up 2. So that would be our shape, and the origin's been moved to -1, 2. Y equals -2 to the power of minus x. Basic curve is 2 to the power of x. Reflects in the origin. See, it's -2 minus x. So it's both reflecting in the x-axis and reflecting in the y-axis. So that's our rotation of 180 degrees. Reflects in the origin. All right, so 4A, 4B. Let's play.